What if humanity's ultimate survival depended on building a structure so massive it could encase an entire star? This isn't just science fiction. It's a concept that could redefine our place in the universe. A sphere, a megastructure capable of capturing all the energy of a star, has long been a tantalizing idea in the realm of speculative science. But what would it actually take to create one? And more intriguingly, what would life be like if we could live inside it? Today, we're diving deep into the science, the challenges, and the breathtaking possibilities of this colossal concept. From its origins in theoretical physics to its potential to transform how we think about energy, space, and survival, we'll explore every angle of this futuristic vision. Get ready to embark on a journey into the extraordinary, a future where humanity might call a sphere home. When we talk about harnessing the power of a star, the sphere is one of the most audacious concepts ever conceived. Picture this: a colossal structure built on a scale so vast it could surround an entire star, capturing every ounce of its energy. This isn't just science fiction, it's a theoretical solution to one of humanity's greatest challenges: energy. The idea was first introduced by physicist Freeman in 1960, not as a solid shell, but as a swarm of solar-collecting satellites orbiting a star. These satellites, working in unison, would gather the star's energy and beam it back to a civilization in need. Over time, the concept expanded, morphing into visions of a solid sphere or even a network of habitats encircling the star, creating a self-sustaining ecosystem for an advanced society. The core idea behind a sphere is efficiency. Stars like our Sun emit an unimaginable amount of energy, most of which radiates into space, unused. A sphere would allow a civilization to tap into this resource, meeting energy demands far beyond what's possible with planetary-based systems. This level of energy consumption is characteristic of a Type II civilization on the scale, a framework that measures a society's technological advancement based on their ability to harness energy. For a civilization to reach this stage, they would need to think on a cosmic scale, and the sphere represents the pinnacle of that ambition. What's fascinating is how this concept straddles the line between imagination and reality. While we don't yet have the technology to build something this massive, the principles behind it are grounded in physics and engineering. It's a reminder that the most extraordinary ideas often begin as mere speculation before evolving into tangible possibilities. The sphere isn't just a dream, it's a glimpse into what humanity could achieve if we dare to think beyond the confines of our planet. To grasp the true magnitude of a sphere, we need a way to measure just how far humanity would have to go to build one. Enter the scale, a visionary concept introduced by astrophysicists in the 1960s. This scale ranks civilizations based on their ability to harness energy, painting a vivid picture of our potential future. Right now, humanity is classified as a Type 0.7 civilization. We've made incredible strides with technologies like solar panels and wind turbines, but we're still largely dependent on finite resources like oil and coal. A Type 2 civilization, the kind that could construct a sphere, operates on an entirely different level. Such a society wouldn't just use energy from its planet, it would tap into the total output of its star, capturing every photon of sunlight to power its unimaginably advanced society. To put this in perspective, a Type 2 civilization would have access to energy billions of times greater than what we currently produce. That's the kind of leap we're talking about. But what would it actually take for us to reach this level? For starters, we'd need to master technologies that don't even exist yet. Things like self-replicating machines, advanced materials capable of withstanding the harsh conditions of space, and energy transmission systems that could beam power across vast distances. Plus, we'd need to solve the logistical challenges of constructing something on the scale of a sphere, which would require moving and assembling unfathomable amounts of material. Some experts argue that reaching Type 2 status is inevitable, given enough time and innovation. Others believe it's a pipe dream, pointing to the countless obstacles we'd face along the way. But whether or not we ever achieve this milestone, the scale gives us a fascinating framework for thinking about our place in the universe, and just how much potential we have yet to unlock. After all, from where we stand today, the idea of harnessing the power of a star might seem impossible. But so would landing on the moon to someone living in the 1800s. The question isn't just whether we can reach Type 2, it's whether we're willing to dream big enough to try. Picture the sun for a moment, its sheer enormity, its relentless nuclear reactions, the staggering energy it radiates every second. Now consider this. The sun emits more energy in 1 second than humanity has used since the dawn of civilization. That's not an exaggeration. It's a testament to the untapped potential of a single star. A sphere, if we could build one, would allow us to harness that energy on an unprecedented scale, unlocking possibilities that sound like science fiction. But let's break it down into something tangible. The sun's energy output is roughly 386, a number so vast it's almost meaningless to our everyday understanding. To put it in perspective, the entire planet Earth consumes around 18 terawatts of energy annually. That means the sun produces more energy in 1 second than we use in a year. A sphere, by capturing even a fraction of that output, could provide enough power to sustain trillions of people, fuel advanced technologies we can barely conceive of, and propel us across the stars. But how would we store and distribute all that energy? One possibility lies in advanced energy storage systems, like quantum batteries or matter-antimatter reactors, which could efficiently hold and release vast amounts of power. Alternatively, we could beam energy across vast distances using directed microwave or laser systems, creating a galaxy-wide energy grid. Imagine a civilization where energy scarcity is a thing of the past, where every colony, every ship, every city has access to limitless power. The implications are staggering. With this kind of energy abundance, we could terraform planets, build megastructures, and explore the furthest reaches of space. Our technology would leap forward, enabling breakthroughs in artificial intelligence, quantum computing, and materials science. Even the most ambitious projects, like creating artificial habitats or traveling to distant star systems, would become feasible. Yet with such power comes responsibility. How would we manage such an energy surplus? Would it unite us as a species, or would it become a source of conflict? These are questions we'd need to answer as we step into this new era. But one thing is certain, a sphere wouldn't just change our energy consumption. It would redefine what it means to be a civilization. Building a sphere is the kind of project that makes even the most ambitious engineering feats of today seem modest by comparison. To grasp the scale, think about this. We're talking about constructing a structure that could completely encompass a star, capturing its energy output. The raw materials alone would be staggering. For a sphere the size of Earth's orbit around the sun, you'd need enough matter to cover an area millions of times larger than our planet. Where would we even find that much material? Some theories suggest dismantling entire planets or mining asteroids in, but even then, the logistics are mind-boggling. Then there's the question of construction. Building something on this scale wouldn't just be a matter of assembling prefabricated parts. We'd need entirely new technologies, ones that can handle extreme temperatures, radiation, and the intense gravitational forces exerted by a star. Imagine trying to create materials that don't just survive in these conditions but thrive, maintaining structural integrity over centuries or even. And let's not forget the sheer distance involved. Coordinating a project like this across interstellar space would require unprecedented levels of automation, communication, and precision. Even our most advanced robotics and AI systems today would need to evolve dramatically to tackle such a challenge. But perhaps the biggest hurdle isn't just the engineering, it's the coordination. A project of this magnitude would demand global, if not interplanetary, collaboration. Think about the Manhattan Project or the International Space Station, but on a scale that dwarfs both combined. Every step, from resource gathering to assembly, would need to be meticulously planned and flawlessly executed. One misstep, one miscalculation, and the entire endeavor could fall apart. So, could humanity ever achieve something like this? It's hard to say. Right now, the challenges seem insurmountable, but history has shown us that what seems impossible today might just be the next generation's reality. The question isn't just about whether we can overcome these obstacles. It's about whether we're willing to commit to the long, arduous journey of innovation and collaboration that would make it possible. And that's a question worth asking as we look to the stars. One of the most fascinating aspects of building a sphere is the sheer scale of the challenge. It's not just about engineering, it's about solving problems on a level we've never attempted before. This is where artificial intelligence comes into play. Picture a swarm of self-replicating machines, tirelessly working in the vacuum of space, assembling structures piece by piece. AI could take on the immense burden of planning, coordinating, and executing tasks that would overwhelm even the most advanced human teams. Think about the complexity of designing something as vast as a sphere. Every component would need to be precisely calculated, from the placement of solar collectors to the distribution of energy. Artificial intelligence could analyze countless variables in real time, optimizing the design for efficiency and stability. It's like having a master architect, engineer, and project manager all rolled into one, capable of processing data at speeds far beyond human capability. But it's not just about design. AI could also revolutionize the construction process. Imagine autonomous robots, guided by sophisticated algorithms, assembling massive structures in zero gravity. These machines could work around the clock without fatigue, adapting to unexpected challenges as they arise. Self-replicating machines could even manufacture additional units on site, reducing the need for constant resupply from Earth. This kind of automation would make the project feasible on a timeline that would otherwise be unthinkable. Maintenance would also be a critical role for AI. A sphere would require constant monitoring and repair to ensure it functions optimally. AI-driven systems could detect and address issues before they become major problems, from micrometeoroid impacts to wear and tear on solar panels. This level of proactive maintenance would be essential for the long-term sustainability of such a megastructure. The question is, could AI be the key to turning this dream into reality? While the technology is still evolving, the potential is undeniable. By combining human ingenuity with the precision and speed of artificial intelligence, we might just unlock the ability to achieve what once seemed impossible. It's a partnership that could redefine our place in the universe, taking us one step closer to harnessing the full power of a star. As we marvel at the idea of a sphere harnessing the boundless energy of a star, it's worth pausing to ask, what might this mean for the cosmos itself? While the promise of clean, renewable power is undeniably appealing, the sheer scale of such a project could ripple across the universe in ways we've yet to fully understand. For starters, encasing a star in a massive structure could fundamentally alter its natural. Stars are dynamic, evolving entities, and a sphere might interfere with processes like solar flares or the eventual expansion into a red giant. If we disrupt these natural phenomena, could we inadvertently accelerate the star's demise, or even destabilize the delicate balance of its energy output? Then there's the impact on surrounding planetary systems. Imagine a star's light dimming or shifting as it's enveloped by a sphere. This change could trigger a cascade of effects, from plunging nearby planets into perpetual darkness to altering their climates in unpredictable ways. Even the gravitational forces exerted by the sphere's construction could disturb the orbits of nearby celestial bodies, potentially sending them spiraling out of alignment. These are not just hypothetical concerns. They're potential realities we'd need to confront if we ever attempted such a monumental project. Beyond the physical consequences, there are profound ethical questions to consider. Is it our right to interfere with a star, a cosmic force that has shaped the universe for billions of years? What responsibilities do we have to preserve the natural order of the cosmos, even as we seek to meet our own needs? These questions push us to weigh our ambitions against the broader implications for the universe itself. Perhaps there's a middle ground, a way to harness stellar energy without enveloping the star entirely. Technologies like swarms, which collect energy without completely encasing the star, could offer a more sustainable path forward. As we dream of a future powered by the stars, it's crucial to balance our ingenuity with a deep respect for the cosmic environment we're part of. Life inside a sphere would be unlike anything humanity has ever experienced. Picture stepping onto the inner surface of this colossal megastructure, where the entire interior is bathed in the warm, consistent glow of artificial sunlight. The scale alone would be awe-inspiring, cities sprawling across vast landscapes, interconnected by advanced transportation systems, all contained within a self-sustaining environment. Here, artificial gravity would mimic Earth's pull, allowing people to walk, work, and play just as they would on our home planet. Yet, the sheer magnitude of the space would create a sense of endless possibility, as if the entire civilization lived within a world without boundaries. Communities inside a sphere would likely develop unique ways of life shaped by their environment. With carefully engineered ecosystems, every habitat could support a balance of flora and fauna, ensuring resources like food, water, and air are always available. This self-sufficiency would eliminate many of the challenges we face on Earth, such as resource scarcity or environmental degradation. But with these advancements would come new social dynamics. How would societies organize themselves in such a vast, controlled space? Would traditional concepts of nations and borders dissolve, replaced by a unified global, or even interstellar, community? The cultural shifts could be profound as people adapt to a life where their entire world is artificially designed. Psychologically, living within a sphere would present its own set of challenges. While the structure would provide everything needed for survival, the absence of a natural sky or familiar celestial landmarks might lead to a sense of disconnection from the universe. Imagine looking up and seeing not stars or a sun, but an endless, engineered landscape stretching overhead. This could inspire both wonder and existential questions about humanity's place in the cosmos. On the other hand, the ability to shape every aspect of the environment might foster a sense of control and optimism, as people work together to create a thriving, harmonious civilization. Of course, with such a monumental shift in living conditions, new challenges would inevitably arise. Maintaining the megastructure's integrity would be a constant priority, requiring advanced technology and coordinated efforts. Social cohesion could also be tested as populations grow and diversify within this confined, yet expansive space. How would humanity ensure fairness and equality in a world where every resource is carefully managed? These questions would shape the daily lives of those living inside a sphere, making it a fascinating blend of opportunity and complexity. Building a sphere isn't just about engineering a megastructure. It's about mastering the cosmos itself. To bring this colossal project to life, we'd need to revolutionize space travel on an unprecedented scale. Think about it. Transporting the sheer volume of materials, workers, and eventually inhabitants across the vast distances of space would require technologies far beyond what we have today. So, what would it take to make this interstellar ambition a reality? First, we'd need propulsion systems that go beyond conventional rockets. Faster-than-light travel, long a staple of science fiction, could become a necessity. Concepts like warp drives, which bend space-time, or antimatter engines, which harness immense energy, might be the keys to bridging the gaps between stars. Even if faster-than-light travel remains out of reach, advanced propulsion methods like ion drives or solar sails could make long-distance travel more feasible, though they'd still require significant time and resources. Then there's the challenge of human endurance. Traveling to a sphere could take decades, if not centuries, depending on its location. Cryogenic hibernation, where humans are placed in a state of suspended animation, could be one solution. Alternatively, generation ships, where entire communities live and reproduce during the journey, might be another. Both options come with their own complexities, from ensuring safety during hibernation to maintaining the psychological well-being of a multi-generational crew. But here, where it gets even more fascinating, a sphere could serve as more than just a home for humanity. It could become a hub for further exploration of the galaxy. With its immense energy resources, it could power fleets of spacecraft, enabling us to venture deeper into the universe than ever before. Imagine it as a cosmic stepping stone, a place where we refuel, resupply, and launch missions to distant stars. Could this megastructure be the first step toward becoming an interstellar species? It's not just a possibility, it could be a necessity. As we push the boundaries of our existence, the sphere might not only redefine how we live, but also where we can go. The technologies developed for its construction and maintenance could unlock the galaxy, turning humanity from a single-planet species into a cosmic civilization. Building a sphere isn't just a technological challenge, it's an economic one on an almost unimaginable scale. Think about it. We're talking about a project that would require materials, energy, and labor far beyond anything humanity has ever attempted. Just sourcing the raw materials alone would likely involve mining entire asteroids, moons, or even planets. And that's before we even consider the costs of developing the technology to move and assemble those materials in space. The price tag. It's safe to say it would be astronomical, both literally and figuratively. But who would fund such an endeavor? Governments, corporations, a global coalition. The sheer scale of the project would demand collaboration on a level we've never seen before. It's not just about pooling resources, it's about aligning priorities across nations, industries, and even generations. And let's not forget the logistical nightmare of managing a global, or even interplanetary, economy to support this effort. Imagine the supply chains, the trade agreements, the currency systems. It would be like building a new economic ecosystem from scratch. Yet, for all the challenges, there's a flip side. A project of this magnitude could spark entirely new industries, from space mining and manufacturing to advanced energy systems and construction technologies. It could create millions, perhaps billions of jobs, both on Earth and in space. The ripple effects could reshape economies, driving innovation and growth in ways we can barely predict. In some ways, a sphere could become the ultimate economic engine, propelling humanity into a new era of prosperity. But here's the big question. Could we handle the strain? Would the benefits outweigh the costs, or would the sheer scale of the project push our resources and our resolve to the breaking point? It's a delicate balance, one that would test not just our wallets, but our ability to work together on something so ambitious. The economic implications of a sphere aren't just about numbers, they're about our collective vision for the future. Are we ready to take that leap? Building a sphere isn't just a technological challenge. It's a test of our ability to work together on an unprecedented scale. To achieve something of this magnitude, humanity would need to transcend the boundaries that have often divided us: national interests, political rivalries, even cultural differences. Think about it. This wouldn't be a project for one nation or even a coalition of a few. It would require the collective effort of the entire planet, a level of international cooperation never seen before in human history. History offers us glimpses of what this might look like, for better or worse. Take the International Space Station, for example. It stands as a testament to what we can accomplish when countries like the United States, Russia, Japan, and others set aside their differences to pursue a common goal. Then there's CERN, the European Organization for Nuclear Research, where scientists from dozens of nations collaborate to push the boundaries of particle physics. These projects show us that cooperation is possible, even in fields as complex as space exploration and advanced science. But let's not ignore the darker side of such endeavors. Large-scale projects often come with friction, competition, and even conflict. Consider the race to the moon during the Cold War. While it ultimately led to incredible achievements, it was fueled by rivalry, not unity. When it comes to a sphere, the stakes would be infinitely higher. Who would control it? How would resources be allocated? Would wealthier nations dominate the project, leaving others at a disadvantage? These aren't hypothetical questions. They're issues that could spark real tension, even warfare, if not addressed carefully. And then there's the sheer scale of the challenge. A sphere would require not just collaboration, but a complete reimagining of how we manage global resources and labor. It would demand new systems of governance, perhaps even a global authority tasked with overseeing the project. Could we create such a system without it collapsing under its own weight? Or would the weight of our differences prove too heavy to bear? The question isn't just whether we have the technology to build a sphere, it's whether we have the unity to see it through. Could humanity rise above its divisions to achieve something so monumental? Or would the very process of trying to build it tear us apart? The answer might just define the future of our species. Building a sphere isn't just an engineering challenge, it's a moral crossroads. What responsibilities do we carry toward future generations, and how do we weigh their needs against our ambitions? This project could consume vast amounts of resources, potentially reshaping entire planetary systems. Is it ethical to alter the universe in such a profound way, even if it secures humanity's survival? These are questions that demand serious reflection. Consider the idea of stewardship. Traditionally, stewardship means caring for the resources we've been given, ensuring they're used wisely and preserved for those who come after us. But in the context of a sphere, stewardship takes on a cosmic scale. Are we guardians of the universe, or are we entitled to reshape it for our benefit? Some argue that as intelligent beings, we have a duty to expand and thrive, even if it means transforming the cosmos. Others see this as a dangerous overreach, a violation of the natural order. Then there's the issue of resource exploitation. Constructing a sphere would require harvesting materials on an unprecedented scale, perhaps dismantling planets or mining asteroids. What happens to the ecosystems or potential life forms that might exist in these areas? Even if we're careful, the sheer magnitude of the project raises concerns about unintended consequences. And let's not forget the human cost. A project of this size would likely span generations, with billions of people dedicating their lives to its construction. Who decides who bears the burden of this effort? How do we ensure that the benefits are shared equitably across societies and nations? These aren't just logistical challenges, they're deeply ethical ones. At its core, the debate over a sphere forces us to confront who we are as a species. Are we explorers, builders, and innovators, driven to push boundaries and reshape our environment? Or are we caretakers, bound by a duty to preserve and protect the universe we inhabit? There's no easy answer, but these questions remind us that progress isn't just about what we can do, it's about what we should do. How we approach these dilemmas will define not just the future of humanity, but our legacy in the cosmos. It's a reminder that every great leap forward comes with a responsibility to think deeply about the consequences of our actions. Before we even had the technology to seriously consider building a sphere, science fiction was already painting vivid pictures of what such a structure might look like. From the pages of classic novels to the silver screen, these imaginative works have not only entertained us, but also pushed the boundaries of what we believe is possible. Think about it. When Olaf first introduced the idea of a star-encircling megastructure in his 1937 novel, Star Maker, it was pure speculation. Yet, that spark of creativity planted a seed in the minds of scientists and engineers, including Freeman himself. Fast forward to today, and you'll find countless examples of spheres and similar megastructures in popular culture. Shows like Star Trek and movies like Interstellar have brought these concepts to life, making them feel tangible and real. But it's not just about entertainment. These stories challenge us to think bigger. They ask questions like, what if we could harness the power of an entire star? Or how far can humanity's ambition truly take us? In a way, science fiction acts as a testing ground for ideas that might one day drive real-world innovation. The connection between fiction and scientific progress is deeper than you might realize. Many of the technologies we take for granted today, smartphones, tablets, even the internet, were first imagined in the pages of science fiction long before they became reality. The same could be true for spheres. While we're still far from constructing one, the stories we tell today could shape the way future generations approach the challenge. After all, every great invention starts with a single question. What if, as we peer deeper into the cosmos, one question looms larger than most? If intelligent life exists beyond Earth, could they have already achieved the monumental feat of constructing a sphere? The search for these megastructures isn't just a flight of fancy. It's a serious scientific endeavor that could reshape our understanding of the universe. Astronomers and astrophysicists are using cutting-edge telescopes and instruments to scan the galaxy for telltale signs of these colossal constructs. But what exactly are they looking for? A sphere, if it exists, would likely emit distinctive signatures. Imagine a massive structure completely enveloping a star, capturing its energy. Such a megastructure would block or redirect starlight, creating unusual patterns in the light we observe from Earth. Advanced tools like the James Space Telescope and projects like SETI are trained to detect these anomalies. Shifts in infrared radiation, unusual dimming, or even unexplained heat emissions. These could potentially signal the presence of a sphere, or at least something equally extraordinary. But what if we actually found one? The implications would be staggering. Discovering a sphere wouldn't just confirm the existence of an advanced civilization, it would suggest that humanity isn't the only species capable of harnessing the energy of stars. It would force us to rethink our place in the universe, challenging the notion that we are alone. Could this be the first step toward joining a cosmic community of star-harvesting civilizations? The idea is both thrilling and humbling. Of course, the search isn't without its challenges. Differentiating between natural phenomena and artificial megastructures requires precision and patience. False positives are a risk, and the vastness of space makes the hunt like looking for a needle in a galaxy-sized haystack. Yet, the potential payoff, proof that we're not alone, makes the effort more than worthwhile. So, as we continue to explore the stars, the search for spheres remains one of the most exciting frontiers in science. It's a quest that blends curiosity, ingenuity, and a deep desire to connect with something greater than ourselves. And who knows? The next discovery might not just change science, it might change everything we know about life in the universe. Imagine a computer so powerful it could solve problems in seconds that would take traditional systems millions of years. That's the promise of quantum computing, a technology that might just hold the key to designing and building a sphere. Unlike classical computers that rely on binary code, quantum computers use qubits, which can exist in multiple states simultaneously. This allows them to process vast amounts of data and tackle incredibly complex calculations, something we'd need in spades to bring a sphere to life. One of the biggest challenges in constructing a sphere is the sheer scale of the engineering involved. We're talking about managing materials, energy flows, and structural integrity on a cosmic level. Quantum computing could optimize these processes by simulating different scenarios at lightning speed, helping us find the most efficient solutions. For instance, it could determine the best materials to use, how to distribute them across the sphere, and even predict potential failures before they happen. But it doesn't stop there. Quantum technology could also help us model the behavior of stars, specifically our sun. Understanding how a star's energy fluctuates and how it interacts with its environment is crucial for a sphere's design. Quantum simulations could give us unprecedented insights into stellar dynamics, allowing us to predict solar activity and design a sphere that can adapt to changes in energy output. Then there's the challenge of coordinating the construction itself. Building something on this scale would require precise planning and real-time adjustments. Quantum computing could manage these complexities by analyzing data from sensors and making split-second decisions, ensuring that every part of the project stays on track. So, could quantum computing be the breakthrough we need to make a sphere a reality? It's certainly a strong contender. By unlocking new ways to solve problems and process information, it could bridge the gap between science fiction and science fact. While we're still in the early stages of quantum technology, its potential to transform how we approach such ambitious projects is undeniable. And as research progresses, the dream of harnessing the power of a star might just move closer to becoming a tangible goal. Living inside a sphere wouldn't just reshape our environment, it could fundamentally alter the trajectory of human evolution. Picture a civilization thriving in an enclosed, artificial world, where the sun's energy is harnessed completely. Over countless generations, this kind of existence might lead to significant biological and cultural shifts. For instance, our bodies could adapt to a controlled climate with minimal exposure to natural elements like wind, rain, or even varying levels of gravity. Over time, we might see changes in our physical structure, from bone density to metabolic rates, as our species acclimates to this entirely new way of life. But evolution isn't just about biology, it's also about culture. In a sphere, our social systems and relationships could transform in ways we can barely predict. With resources potentially abundant and survival less of a daily struggle, humanity might shift its focus toward creativity, exploration, and technological innovation. However, this could also raise questions about identity and purpose. What does it mean to be human when we're no longer shaped by the challenges of a natural world? How do we define progress in a society that exists within the confines of a megastructure? Advancements in genetic engineering could further accelerate these changes. Imagine a future where we have the ability to enhance our bodies to thrive in artificial environments. We could develop resistance to radiation, optimize our energy efficiency, or even extend our dramatically. These technologies might allow us to evolve at a pace far quicker than natural selection ever could. Yet, this raises ethical dilemmas. Who gets access to these enhancements? Would we risk creating societal divides between the genetically modified and the unmodified? And then there's the question of how living in the shadow of a star might shape our collective psyche. A sphere represents humanity's ultimate triumph over nature, but it also signals a departure from the earth-bound existence that has defined us for. Would this isolation from the natural world lead to a sense of detachment? Or would it inspire us to reach even further, perhaps to other stars and galaxies? The truth is, the evolution of humanity in a sphere would be a complex interplay of biology, technology, and culture. It's a future where we might not only build megastructures, but also redefine what it means to be human. And as we peer into that possibility, one thing becomes clear. Our species is capable of extraordinary transformation when faced with extraordinary challenges. The concept of a sphere is undeniably awe-inspiring, but it's worth asking, do we really need something so colossal to solve our energy problems? After all, humanity has made remarkable strides in renewable energy already. Fusion reactors, for instance, are often called the holy grail of clean energy. Imagine harnessing the same power that fuels the stars right here on Earth. While fusion is still in its experimental stages, breakthroughs like the International Thermonuclear Experimental Reactor are bringing us closer to a future where this limitless energy source could become a reality. Then there's solar power, which has evolved far beyond the rooftop panels we're familiar with. Cutting-edge technologies like orbital solar arrays could capture sunlight without the interference of Earth's atmosphere, delivering energy around the clock. And let's not forget wind, geothermal, and tidal energy, each offering unique ways to tap into the planet's natural systems. These innovations might not be as flashy as a sphere, but they're practical, scalable, and most importantly, achievable within our lifetimes. So, is a sphere the only path forward? Not necessarily. While it's a fascinating vision, it's also a monumental challenge, one that might not even be necessary if we can master the energy sources already within our reach. The real question is whether humanity will have the foresight and determination to pursue these alternatives before our energy needs outstrip our ability to meet them. After all, the future isn't just about building megastructures. It's about finding sustainable solutions that work for everyone. Living inside a sphere wouldn't just be a technological or logistical challenge. It would test the very fabric of human psychology. Imagine spending generations in an artificial environment millions of miles from Earth, with no sky, no natural seasons, and no direct connection to the planet that shaped our evolution. The isolation alone could weigh heavily on the human mind. Without the familiar rhythms of life on Earth, people might struggle with feelings of rootlessness or disconnection. After all, our planet isn't just a place we live. It's a part of who we are, embedded in our culture, art, and even our biology. One of the biggest psychological hurdles would be the sense of confinement. Even in a structure as vast as a sphere, the knowledge that you're surrounded by walls instead of an open horizon could feel suffocating. Think about how we feel after spending too much time indoors. Now amplify that by centuries. The lack of natural light, fresh air, and the ability to roam freely could lead to increased stress, anxiety, or even depression. And with entire generations born and raised in this environment, the concept of home might shift entirely, leaving people adrift in a world that feels both immense and claustrophobic. But humanity has always been resilient, and there are ways to address these challenges. One key strategy would be creating a strong sense of community. In a sphere, social bonds would be more important than ever. Shared goals, collaborative projects, and cultural traditions could help people feel connected to something larger than themselves. Virtual reality could play a role here, offering immersive experiences that simulate the sights and sounds of Earth, from forests to oceans, helping to alleviate feelings of disconnection. Another critical factor would be psychological support systems. Counseling, mental health resources, and regular check-ins would be essential to ensure people feel heard and supported. Activities like group exercises, art therapy, or even gardening in artificial green spaces could provide a sense of purpose and normalcy. And with advanced technology, we might even develop new ways to monitor and support mental health, using AI or brainwave analysis to detect and address issues before they escalate. Ultimately, life inside a sphere would require us to redefine what it means to be human. It's not just about surviving in space, it's about thriving, finding new ways to adapt, and ensuring that our mental and emotional well-being keeps pace with our technological advancements. As we ponder this future, one thing is clear: the psychological challenges would be as significant as the engineering ones, and addressing them would be key to making life in a sphere not just possible, but fulfilling. To bring a sphere from the realm of science fiction into reality, we'd need more than just advanced technology. We'd need a revolution in how we think, learn, and innovate. Picture this: an entire generation of thinkers, engineers, and visionaries working together to solve challenges that seem insurmountable today. But how do we prepare for such a monumental task? The answer lies in education, particularly in the fields of science, technology, engineering, and mathematics, or STEM. Imagine classrooms where students aren't just memorizing formulas, but actively engaging in projects that simulate the problems they'd face in constructing a sphere. Think of young minds being encouraged to experiment, fail, and iterate, building resilience and creativity along the way. This isn't about rote learning. It's about fostering a mindset that thrives on curiosity and collaboration. But STEM alone isn't enough. Interdisciplinary collaboration would be crucial. After all, building a sphere isn't just an engineering challenge. It's a test of how well we can integrate ideas from physics, materials science, biology, and even philosophy. What if artists and designers worked alongside scientists to create blueprints that are not only functional but also sustainable? What if ethicists and sociologists helped us navigate the societal implications of living in such a megastructure? This future requires more than just technical expertise. It demands a cultural shift. We'd need to value creativity and problem-solving as much as we value traditional academic achievements. Schools, universities, and even workplaces would have to become hubs of innovation, where failure is seen as a stepping stone rather than a roadblock. The question isn't just whether we can build a sphere, but whether we can build the kind of society capable of envisioning and constructing one. Education and innovation are the tools that will unlock this potential. By investing in the next generation of thinkers and doers, we're not just preparing for a sphere, we're preparing for a future where humanity can achieve the extraordinary. Building a sphere wouldn't just be a scientific or engineering challenge. It would be a monumental organizational and political endeavor. Governments and private corporations would likely find themselves at the center of this colossal project, each bringing unique resources, expertise, and motivations to the table. But how would these two forces collaborate, and what tensions might arise? Public-private partnerships could be the key to pooling the necessary funds and talent. Governments might provide the long-term vision and regulatory framework, while corporations could bring innovation and efficiency. Yet, the scale of such a project could also spark conflicts of interest. Who gets to decide how resources are allocated? Who benefits the most from the energy harvested? These questions would shape the very foundation of the project. Governance would become a critical issue. A sphere wouldn't just be a piece of infrastructure. It would be a global asset, potentially altering the balance of power on Earth. Would it be managed by a single nation, a coalition of countries, or an international body? And how would accountability be ensured in such a massive, high-stakes undertaking? The decisions made here wouldn't just affect the construction of the sphere. They would ripple across generations, shaping the future of humanity itself. Building a sphere wouldn't just be a technological triumph. It would redefine what it means to be human. Think about it. This colossal structure, encircling a star and harnessing its energy, would stand as a testament to our ingenuity, ambition, and ability to dream beyond the limits of our planet. It would be a symbol of what we can achieve when we work together on a scale that transcends borders, cultures, and generations. The legacy of a sphere wouldn't just be measured in megawatts or light years. It would be etched into the very fabric of our collective identity. Culturally, the impact would be profound. Throughout history, humans have built monuments that reflect their values and aspirations, from the pyramids of Giza to the International Space Station. A sphere would be the ultimate monument, not just to our survival, but to our desire to thrive. It could inspire art, literature, and philosophy, becoming a cornerstone of how we see ourselves in the universe. Imagine the stories that would emerge, tales of courage, collaboration, and the boundless possibilities of the human spirit. It would remind us that we are more than just inhabitants of a tiny planet. We are creators, explorers, and dreamers. Scientifically, the ripple effects would be immense. The technologies developed to construct a sphere, advanced materials, energy systems, and interstellar engineering would revolutionize countless fields. The knowledge gained could lead to breakthroughs we can't yet imagine, from new forms of energy to deeper insights into the nature of stars and space. But perhaps the most profound scientific legacy would be the mindset it would instill. Tackling a project of this scale would require us to think bigger, to push the boundaries of what we believe is possible. It would set a precedent for future generations to aim for the stars, literally and figuratively. Philosophically, a sphere would force us to confront fundamental questions about our place in the cosmos. Are we destined to remain tied to Earth, or is our future among the stars? What does it mean to harness the power of a star, and what responsibilities come with that power? These questions could reshape how we view ourselves, our planet, and our role in the universe. It might even spark a new era of global unity, as we realize that the challenges and opportunities of such a project belong to all of humanity, not just a single nation or group. And let's not forget the inspiration it would provide. Just as the Apollo missions inspired a generation of scientists, engineers, and dreamers, a sphere could ignite a new wave of innovation and discovery. It would show us that no goal is too ambitious, no problem too complex, no dream too far out of reach. Future generations might look back at this project as the moment when humanity took its first real step toward becoming an interstellar species. What would that mean for the story of humanity? It would mean that our story is just beginning, and the possibilities are as vast as the universe itself. As we look ahead, the concept of spheres could transform dramatically with advancements in technology and our understanding of the cosmos. Right now, these megastructures exist mostly as theoretical constructs, but that could change. One intriguing possibility is the development of partial swarms, smaller, more manageable collections of energy-collecting satellites orbiting a star. These swarms could serve as stepping stones, allowing us to gradually scale up to a full sphere. But why stop at one star? Imagine harnessing the energy of multiple stars in a system, creating a web of interconnected megastructures that could power entire civilizations on an unimaginable scale. The idea of other civilizations building their own spheres adds another layer of fascination. If humanity ever achieves this feat, could we detect similar projects elsewhere in the galaxy? Advanced civilizations might already be constructing these energy-harvesting networks, creating a cosmic grid that spans star systems. This raises questions about communication, cooperation, or even competition among interstellar societies. Could we one day be part of a galaxy-wide energy-sharing community? Or would we find ourselves in a race to harness the most resources before others do? Looking even further ahead, the materials and methods used to build spheres might evolve in ways we can't yet predict. New discoveries in physics or engineering could unlock technologies that make these megastructures more efficient, durable, or even self-sustaining. Imagine a sphere that not only collects energy but also repairs itself, adapting to the challenges of space over thousands or even millions of years. The possibilities are as vast as the universe itself, and the future of spheres may hold surprises that redefine our understanding of what's possible. What role will humanity play in this grand cosmic endeavor? And what might we discover along the way? The concept of living inside a sphere is nothing short of extraordinary, a vision that stretches the boundaries of what we believe is possible. It's a reminder of how small we are in the grand scheme of the universe, yet how vast our potential can be when we dare to dream. Throughout this exploration, we've seen the monumental effort it would take to bring such a structure to life. The technological leaps, the global collaboration, and the sheer audacity to attempt something of this scale. But with great challenges come even greater rewards. Imagine a future where energy is no longer a concern, where we can venture into the stars with ease, and where humanity takes its place as a truly interstellar species. It's a future that feels both distant and tantalizingly within reach. So, what's your take? Do you think humanity could one day thrive within the embrace of a sphere? Let us know your thoughts in the comments below. We'd love to hear your perspective. And if you're as fascinated by the possibilities of tomorrow as we are, make sure to hit that subscribe button for more journeys into the unknown. The future is waiting, and it's ours to shape.